Logarithms. Now we are familiar with the process of mathematics turning words to symbols. Okay, and the whole idea is to describe what we perceive. So when we hear the word logarithms, in words, you can say the logarithm of a number is equal to the exponent. Okay, that base has to be raised to equal to that number. Okay, now these are words, right? I mean, obviously we can clearly see these are words. This sentence can be converted to symbols. The logarithm for number, oh, not just a number now. sorry, I knew something was missing because it was looking like a little, something was missing. The logarithm of a number in a particular base. in a particular base. And actually, this is one of the most important areas in that definition. Is equal to the exponent, that another word for exponent is power. All right, that the base has to be raised to equal to that number. Okay, so symbolically now, the symbol for logarithm is log. All right, symbol for logarithm is log. So the logarithm of a number, the logarithm of a number. So the logarithm of a number symbolically is this. So when you see that, you have to say the logarithm of a number. Okay, log of n for short, but is properly said the logarithm of a number. So you see your words turn into symbols in a particular base. So that's where the base is normally placed after the g. It's just like sine squared x. Instead of putting the base by the end, you know, it or you can see the logarithm in a particular base of a number. Okay. The logarithm in a particular base. So in a particular base, let's get the base to equation, script, subscript, and b for base of a number is equal to the power. There are different letters we can use for power. Let's use x. Let's use x. You can use p for power, you know, but let's use x. Okay, or we can use y. Let's do y. So let's do it as x. Doesn't matter. All right. So this and that is expressing the same thing. The logarithm in a particular base of a number is equal to the exponent that the base has to be raised to be equal to the number, to that number. So therefore now, according to this definition, this symbolic expression can be rewritten and it is communicating the same thing. It can be rewritten now in exponential format. Okay, because this is saying that the base, you see the base has to be raised. Okay, to that x. Okay, because that x now is an exponent. Once you see you have logarithms, logarithm is present by itself, nothing plus or minus anyway, but it by itself, whatever is equal to is a power, you know. Whatever it is equal to is an exponent. Whatever comes after the equal sign is an exponent of the base to be equal to that number. Okay, so the base has to raise to the exponent to equal that number. Okay, so this is very important to transit from exponential form to logarithmic form and back and forth, from logarithmic to exponential, exponential to logarithmic, because that is what is actually going on, is to deal with functions or deal with equations that has exponents, all right? And that is to facilitate the solution of functions thereof. So just, you know, bear that in mind as an introduction to the whole topic of logarithm.